Good morning everyone. I am Krishna from CSEC section. Today I am explaining about chain growth and step growth polymerization. Introduction of polymerization. Polymerization is the chemical process that combines small molecules called monomers into large molecule complex structures known as a polymer. This process can be broadly categorized into two main types: chain growth and step growth polymerization. Understanding the difference between this method is crucial for applications in materials science, chemistry, and engineering. Chain growth polymerization overwise. Chain growth polymerization involves the sequential addition of monomers to an active site of a growing polymer chain. It is typically requires an initiator to start the reaction, which generates free radicals or cations. The process is chain react categorized by rapid growth of the polymer chain, leading to high molecular weight products. Mechanism of chain growth polymerization. The mechanism can be divided into three main steps: initialization, propagation, and termination. In the initialization step, an initiator reacts with a monomer to create an active center starting the chain. Propagation continues as additional monomers and to the active center, while termination occurs when two active chains combines are deactivated. Types of chain growth polymerization. There are mainly three types of chain growth polymerization: free radicals, ionic, and coordination polymerization. Free radical polymerization is the most common and involves free radical as initiator. Ionic polymerization can be either cationic or anionic depending on the nature of the initiating species. Step growth polymerization overwise. Step growth polymerization, also known as condensation polymerization, involving the reaction between two or more multifunctional monomers. Unlike chain growth, the molecular weight increases gradually as monomers react in a stepwise fashion. This method often produces byproduct such as water or methanol depending on the monomers used. Mechanism of step growth polymerization. The mechanism of step growth polymerization does not rule on an initiator but rather on the direct reaction of functional groups. The reaction can occur between monomers with two or more reactive sites, facilitating the formation of large molecules. The process continues until the monomers are consumed or the reaction reaches equilibrium. Key difference between chain growth and step growth. One of the main differences in the chain growth requires an initiator while step growth does not. Chain growth polymerization typically results in high molecular weight polymers quickly, whereas step growth results in gradual molecular weight increases. The distribution of molecular weight is such is much broader in step growth compared to the relativity informed chain product in the chain growth. Application of chain growth polymerization. Chain growth polymerization is extensively used in the product of plastics such as polyethylene and polystyrene. It is favored for applications requiring materials with specific properties like flexibility and strength. The ability to control the molecular weight and structure of the polymers makes it valuable in various industries, including packaging and automotives. Application of step growth polymerization. Step growth polymerization is commonly used to create polymers, poly, polyamides, and other high performance materials. These polymers are essential in applications such as fibers, resins, and coating due to their thermal and mechanical properties. The process is also important in the product of specialty polymers with tailored functionalities. Conclusion. Both chain growth and step growth polymerization have distinctive mechanism and applications in polymer science. Understanding this difference allows for better selection of the method for specific polymer application. Continued research in polymerization techniques can lead to the development of new materials with enhanced properties, free, free to modify any content of formatting as needed. Thank you.